Hello students, you are welcome to sirMATHS. We are going to discuss sets, and our discussion is for grade 12, equivalent to XX3. We are just going to review what you are supposed to have known. Thereafter, we go to Venn diagram. That's the application of set. That will be the next thing after this. It is good we review the symbols of set. Remember to subscribe to sirMATHS to follow us on this daily journey in mathematics world. It is an exciting, it is good, and it's very helpful in life. So don't fail to do that. Like I was saying, we are treating sets. The preliminary of sets is a review of what we are supposed to have known because we have treated sets in our lower grade. Now we have the symbols of set here. What we have here is known as a subset. It's a subset. What is a subset? A subset is a part of something, a fraction of something. Like in a secondary school, SS3, SS2, the two, or even one of them is a subset of the whole school, a part of something, a fraction of something. In a set theory, or in set, if a set contains some element and another set contains a part, some of those elements, not completely, we now say that that other set is a subset of the previous one. What I mean is if set A, assuming we have set A to be 1, 2, 3, 4, and we have set B to be 2, 4. We now say that set B is a subset of set A. Everything in set B is contained in set A. And set A must have more elements than set B. So set B is a subset of set A. That is for this symbol. We use this for subset. That is for that. Now, this is universal set, or rather union. This is union. We have now come to universal set. This is union. What is union? Union is a gathering together of different sets. It's a gathering together, a bigger umbrella that cover, like in a school, if SS3A is merged to SS3B, that becomes the union of SS3A and SS3B union. In the world, we have union, the National Union of Teachers, one union or the other. It means the bigger umbrella that covers those in that profession. So when we are talking of union, union is gathering together of more than one set. We call the result as union. It could be union of set A and set B and whatever. So that is, this is for union. We have this symbol, either this or this. They are just saying the same thing, they are the same thing. This is universal set. Universal set. Universal set is the enlarged set that all other sets are part of it. When we are talking of our country, different countries in the world, there is a bigger, a universal set. as we are talking of the countries in the world, the whole world is the universal set. In the secondary school, when we are talking of this class, the universal set is the whole school. When we are talking in months, the universal set is the entire year, the complete year is the universal set. The set that other sets come from. In other words, other sets from this will be referred as subset to this very universal set. You were told that before. Now, this is the negation of a subset. The negation of a subset. When you have this, it then means if you have this A is, this means that A is not a subset of B. It's not. That A is not in B. That is what it means. It's negation of what we said before. Is not a subset. It does not belong. It's not a part. In other words, the element here does not, maybe are not existing in this. So it's not a subset. This is belongs to or is a member of. Belongs to or is a member of. When we say that 5 belongs to prime numbers, we write this, prime numbers. What we mean is that 5 belongs to prime numbers. It belongs to a prime number. 5 is a prime number. That is what it stands for. Here is a negation to this. That it is not, does not belong. It doesn't belong there. No, it's not a member. That is what this symbol stands for. All this is to save your time in mathematics. Mathematics does not want to bother somebody. It simplifies matter. So those long English language, no. Mathematics simplifies it. Once you have written this thing, you have given the whole story. That whatever, it could be an element, it could be a set, does not belong to the set in question. That is what this stands for. Here we have this symbol. This is empty set, which is the same thing as null set. Empty set or null set are the same, which means a set that has no element in it. It does not contain any element in it. So, no term in it. We call that empty set or null set. For example, something that is a set that has no member at all. Maybe presently we can ask ourselves, say, the set of those who are 450 years in a particular country. You discover it to be an empty set because presently we may not get somebody who is up to 450 years now. Yes, in those days it happened in the ancient time. So the set will be empty set because no element, there's nobody of such. This symbol stands for the number of elements in set A. The number of elements in set A. If we have A to be equal to set of 5, 7, 9, 11. Then the number of elements in set A is now equal to 1, 2, 3, 4. Number of elements. We count it 1, 2, 3, 4. So there are 4 elements. This is what means the number of elements in set A. That's what it stands for. This is the complement of set A. The complement of a set is the makeup of that very set. The elements that when you add it to the said set, it will be the same thing, it will be equal to the universal set. The elements in the universal set that does not belong in that very set. Let's assume that A is a set of C, or a set of a universal set, a set from a universal set. So all the elements in that universal set that is not in set A are known as the complement of A. Like I said before, makeup, making it to be equal to the universal set. We call it the complement of that very set. But we pronounce this as A prime. A prime. This is A prime. But what it means is the complement of set A. All the elements in the universal set that do not belong here is what we call the complement of set A. And this symbol stands for the number of elements in a given set. You can see it here, n, which we say is the number of elements in set A. And we give example, let's say set A to be 5, 7, 9, 11. And so the number of elements in this set A, we find it to be 1, 2, 3, 4. 4. So that is what this stands for. The number of elements, just count the elements in that very set. Whatever you get is the n of that very set. That is for the symbol of sets. We also have different sets. We have different sets that we need to know, which we call type of sets. We have finite set. Finite set is a set that has an end. For example, if we have this set, maybe set x equals to 3, 5, 6, 7, 9. This is a finite set. It has an end. It ended at 9. We call this finite set. However, we also have infinite set. Infinite set is a set that has no end. Somebody like you can have a set like set of 1, 2, 3, 4. This has no end. That is continue to infinity. We call it infinite set. It has no end. We have a unit set. A unit set. A unit set is a set that has only one element as a member of that very set. One element there. We call it unit set. Some people call it singleton set, unit set. It has only one element in that very set. For example, we can have a set. Only A is a member. So we call this a unit set because it has only one member, one element in that very set. That is for that. We have proper subset. A proper subset is just the same thing as a subset. That is, it belongs to a particular set. It truly belongs to that very particular set. Is a subset or proper subset. So these are to remind us of all these symbols and all these types of sets. We still have more other sets than the one we have mentioned, which I want to believe you can remember. We have equal set. We have disjointed set. Equal set is a set that has equal elements. If we have set equals set, we have set x to be equal to the set of 9, 11, 13, 14. And we have another set y, which is equal to 1, 2, 3, 4. We are talking of equal set. So they have equal number of elements, but in most cases it will be the same, almost the same thing. That is equal set. Disjointed set, we will amplify it when we start treating Venn diagram. It's a set that does not touch each other. It has no intersection. It has no intersection. Like I said, when we start treating our Venn diagram, we will mention that clearly. This is a disjointed set. You can see they are not touching each other. And that means none of the elements here belongs to this set. None of the elements in this set belong here. The same thing, none of the elements here belong here. They don't touch each other. So we call it disjointed set. They don't have intersection. They don't have intersection. I still hope you still remember what intersection is. Intersection is those elements that belong to two or more sets. The element that belong to two or more sets. For example, in a sports club, somebody who plays football and also play table tennis. When we are drawing a Venn diagram, the set of this, you discover that that person will be in the intersection. It will be, he or she will belong to table tennis and also belong to the other sports. So we call it intersection. Member of element or element that belong to two or more sets is intersection. So when we are talking of disjointed set, we are talking of a set that doesn't touch each other. If this is set A and this is set B, you discover there is nothing in common with the two. So we call it disjointed set because each of them is on its own. It's true they belong to the same universal set, but their members, none of them belong to the other one. That is disjointed set. In our next meeting, we now go to the application of set, and that will lead us to Venn diagram, where we discuss and solve issues that affects us in life. Life application of set will be our next discussion if God tarries. I still appeal to you to subscribe to sirMATHS. Don't fail to do that so that you will be updated, you flow with us, and you discover that mathematics is an enjoyable subject. It is everywhere. In the kitchen, anywhere you are, mathematics is there. It's a good friend, and it shouldn't frighten us. Rather, we make it friendly, and that is what sirMATHS is all about. Making mathematics to be friendly, and indeed it is friendly. Thank you for participating for today. God bless you. In our next meeting, we will discuss the application.